Power to the truth. This is Margo. This is Wednesday, February 13th, 2019, and it's 4:31 p.m. Pacific Time, United States of America. So we're looking at Copernicus Atmosphere Monitoring Services again today. Yesterday we had new data of Saturday the 9th. Today we have new data of Sunday the 10th. I've chosen the Arctic view so that we can get as close up a view as possible of this Arctic region and surface level. So we're going to look at methane, and then I have a new blog post from Sam Carana that I'm going to share. Then we'll go over comments, and then we'll do earthquakes. So it'll be a full report. So sit back and let's see what's going on. So I have this movie loaded up, and it's like we always see, it's a little bit jerky this first time through, and then it smooths out. So the data is from Sunday, and then the forecast period is Monday through Thursday through tomorrow. So I'm going to pause it here. This is where Saturday ended. This is where we ended with this big methane release from this island here, October Revolution Island. And there's a big release all around the island and coming up, and then a dark release to the east of Novaya Zemlya and coming up, and a release coming up through off the land of Siberia, and then another one building in Russia, and then coming up here to the west of Novaya Zemlya, and then a new release building here to the north of Sweden and Finland. So let's run the movie and see. Okay, so by the end of Sunday, here's what had happened. This release continued and spread out in an arc, and it actually reached through the Laptev Sea and over into the East Siberia Sea. This is where that East Siberia ice shelf is, and then it reached all the way down to Svalbard and continued building over Norway and Sweden and Finland here. So let's let it run now, and you can watch it now. It's going into the forecast period where it's continuing to release, heavy release in the Kara Sea here, and then red-orange release up here, even up by the North Pole. So it's spreading out, and it's coming up through the sea ice, and so here it's curling around, and now here's the North Pole, and here it is coming up past and releasing past the North Pole and spreading out again like a spiral. So we can see that it's not slowing down, that it seems to be picking up steam, and methane levels are on the rise along with CO2 levels, which is what I'm going to show in the Sam Carana blog post today. So let's stop that movie there. And now I've got the same data pulled up, but just for the global view. I have the movies started here, so I thought we'd just look at this and everybody could see what the methane is like in your neck of the woods. And so the majority of it we're seeing is a huge release coming up, and then gathering in the Arctic here, and of course China and northern India, and coming across Russia and coming across into Europe. Europe is pretty black. There's this area in Canada that's really releasing a lot, and then pockets are releasing, just depending on the temperature and the moisture here in the United States. And then of course quite a bit coming out of South America and parts of Africa, and that's kind of what we're seeing on the world stage. And for our friends down under, we're seeing some releasing on the northern part of Australia, and some releasing over here on New Zealand. We'd have to go to a different view to get, there's an Australia view, I think, where if we wanted to look a little closer there. In fact, while I'm thinking about it, I thought there was here's Australia. You know, I have not, for whatever reason, used this view very much. I need to start showing it for all my friends down under. I've got a lot of friends down there now in Australia and New Zealand, and so when we zoom in, there is quite a bit of release down here on the surface level. See, around the coastlines and at major areas, see huge release there. And so I will remember to start showing Australia as a matter of course in all of these updates as well. And y'all have had an awful time with the droughts and the flooding, and now a bunch of fires and loss of cattle and livestock and lives, and you know, you've just had a bunch of awful stuff going on. My heart goes out to each and every one of you down there. So let's pause that and put this as a backdrop here. And now let's come over to the article. This is from arcticnewsblogspot.com. This is Sam Carana's blog, and it's a wealth of information from all of the research that he's done. And it's a collaboration of scientists and other researchers who have come together for this blog. So this is from Sunday, February 10th, 2019, and the title says CO2 levels reach another record high. CO2 levels just reached another record high on February 9th, 2019. An average daily CO2 level of 414.27 parts per million was recorded at Mauna Loa, Hawaii. And here's the chart. And so here it is where it was at the highest. And this is a chart that Sam Carana created. And this is the starting with 2014 with CO2 was under 400 parts per million. And then depending on the time of year it goes up and then comes down, goes up, comes down. And but the overall trend is, we can see it's going up year by year. The image below shows hourly red circles and daily yellow circles average CO2 values from Mauna Loa, Hawaii for the last 31 days. And so February 9th, the highest was 414. February 8th was 411. February 7th was 410. February 6th was 411. February 5th was 410. So then he's got ice core data before 1958. And you can, I'll leave the link below and you can see all of this. How much can CO2 levels be expected to grow over the next decade? A recent Met Office forecast expects annual average CO2 levels at Mauna Loa to be 2.75 parts per million higher in 2019 than in 2018. The image below shows NOAA 1959 to 2018 CO2 growth data in the black and uses this Met forecast used for 2019 in the brown. The growth figures for 2018 and 2019 are spot on a trend that is added in line with an earlier analysis. So we can see that in 1980 it started out down here at the growth. This is how much it's growing, parts per million, and it was at 1.5, and then it kind of started going up in 1996, and then gradually going up a little more, and now it's going straight up. So here's 2020. So here's 2019. Here's 2018. And so 2.75 is right there. So strong CO2 growth is forecast for 2019 due to a number of factors, including rising emissions, the added impact of El Niño, and less uptake of carbon dioxide by ecosystems. A recent study warns that global warming will enhance both the amplitude and the frequency of Eastern Pacific El Niño events and associated extreme weather events. Another recent study warns that while the terrestrial biosphere now absorbs some 25% of CO2 emissions by people, the rate of land carbon uptake is likely to fall with reduced soil moisture levels in a warmer world. Furthermore, fire hazards can be expected to grow due to stronger winds and higher temperatures, each of which constitutes a factor on their own, while they jointly also increase two further factors, i.e. drying out of soils, groundwater, and vegetation, and the occurrence of more lightning to ignite fires, and to also cause more ground level ozone that further deteriorates vegetation health. The warming impact of CO2 can therefore be expected to increase over the next decade, given also that the warming impact of CO2 reaches a peak 10 years after emission. The earlier analysis furthermore warns about strong growth in CO2 emissions due to fires in forests and peatlands, concluding that CO2 emissions could cause an additional global temperature rise of 0.5 degrees Celsius over the next 10 years. Well, we're seeing all of that with the fires and the droughts and everything. But then flooding, when it rains, it floods. And snows, oh my God, the snow, we've got another system coming in, and the snow is unbelievable. And of course the West Coast is seeing a lot of snow, and up in Seattle, and it's incredible what's happening. And then he says rise in methane is accelerating. Methane levels are also rising, and this rise is accelerating as illustrated by the image below. And so this graph shows July 1983 to October 2018 monthly global methane means at sea level, with added trend. Higher means can occur at higher altitude. On September 3, 2018, means as high as 1905 parts per billion were recorded at 307 millibars. So here are the years down here. Here was 2010. It was, mean means average. So it was around 1800 in 2010. And then it's been gradually going up. And then here's 2018. And the mean was 60 or 50? Let's see, 1, 2, 3, 4, 5, 6, 1860. But it can be higher. So that's just the average for the year. And the graph shows July 1983 through October 2018 monthly global methane means at sea level with added trend. Note that higher methane means can occur at higher altitude than at sea level. Okay, he's just repeating that information. What does the historic record tell us? At 10 degrees C higher, a 10 degrees C higher temperature is in line with such high greenhouse gas levels as illustrated by the graph below, based on 420,000 years of ice core data from Vostok, Antarctica from an earlier post. Well, 10 degree, and that's equivalent to like 18 degrees Fahrenheit. That we couldn't live. I mean, they already know that at 2C, when it hits 2C, and some of the parts of the planet are already experiencing a 2 to 4C increase. So it's not uniform all the way around the planet, and it's not manageable. Tipping points. The threat is that a number of tipping points are going to be crossed, including the buffer of latent heat, loss of albedo as Arctic sea ice disappears, methane releases from the seafloor, well, we're seeing that, and rapid melting of permafrost on land and associated decomposition of soils, resulting in additional greenhouse gases, carbon dioxide, methane, and nitrogen oxide, and water vapor entering the Arctic atmosphere in a vicious self-reinforcing cycle of runaway warming. So he's saying a 10°C or 18 degrees Fahrenheit temperature rise by 2026 question mark. And then there are further feedbacks that make it go up. So anyway, he's got them all listed by feedbacks, and he says above image shows how a 10°C or 18 degrees Fahrenheit temperature rise from pre-industrial could eventuate by 2026. And he's shown that before. I've seen that chart before, and I like it because he breaks it down into what the different things are. He doesn't mention earthquakes and release of these greenhouse gases from earthquakes, and earthquakes do release these gases as well. But so we can just add that to the mix too. So I will leave a link below if people want to look at this blog post or any other blog post of his. It's a really good website. So now let's go on over to comments. Oh, and by the way, I want to share something. If you look at the description under my YouTube videos, in the description box, I've changed it a little bit, and here's the information that I'm sharing. I share in my description box some of my background videos. If people are not familiar with, these are some of my original research and kind of teaching videos on methane, sulfur dioxide, and volcanic gases, and ozone. And then instead of just putting the links to the websites that I used that day in the show, I put commonly used links, and I've included USGS earthquake site, the EMSC earthquake site. This is the Copernicus website where you enter on cams to the North Pole. Here's Google Earth, Climate Reanalyzer, NASA Worldview, and the Navy military for the Arctic sea ice. And I've decided to add also this link to the Navy military for the polar oceans, and that includes the Arctic, the Beaufort Sea, and the Antarctic. So and then I put show links, and I put just the links that are specific to that show. Like here's the link to Sam Carana's article for today. So I've changed that up a little bit. So you know, if you're looking for a link to one of these sites that I use for my research, just look in the description, and more than likely you'll find it there. And if not, just let me know, and I'll see what I can do. So now let's head over to comments. And Robert Hayes had 3 comments that he left under my show from a couple of days ago. He says, "Hi Margo, I'm wishing the Belusia Guba polar bears the best. They're at coordinates," and then he puts in the longitude and latitude. "I wish we could suggest some nice local fish brought from the Rogachevo Joint Strategic Command North Base nearby. Non-radioactive ones too. I'd imagine that the 1961 Tsar Bomba blast a little further north loosened up some fault lines there. It said that 50 megaton blast was about 5 miles diameter and estimated a fourth of the 1883 Krakatoa blast. Interesting article about the large amounts of radioactive waste, 13 spent reactors, and more scuttled nuclear reactor ships up there." And this is a really good article. I've reported on this before, and this is another really good article about Novaya Zemlya and how it was used as a military, it's still basically a military base, and it was used for nuclear testing during the Cold War. And so all that waste, they dumped it in the ocean. They just dumped it, and it's still there. And so Also, if people are interested, I did a video about Novaya Zemlya back in June, and it's called Novaya Zemlya, the smoking gun for rapid Arctic warming. And so it's quite a long video. It's about 2 hours long, and I did a whole bunch of research into all of that and about the nuclear testing and Tsar Bomba, and it was actually 58 megaton. So, and that was the largest nuclear bomb that was ever detonated. And then they changed the protocols and said they can't be that big anymore. So, yeah, that was right over the island, to the west of the island. And then they did a bunch of testing underground and in the water, and I show it in that video. So thanks for that that report, Robert Hayes, and that article. And yeah, it's a mess up there. And then he says on the methane maps there's always a blue area. By the way, in India and China, which had so much less methane emitted, so we learned that the area is called the third pole today with Paul Beckwith. And that's a link to Paul Beckwith's video about the third pole, and I watched it, and it was really interesting. And he talked about, here, let's go back, I'll show you on cams exactly what he's talking about. Let's go up to the would it be Western Asia? You can see it on the global view, but I wanted to just get a closer view. It's this area up here that's lower in methane. Let's look at it at global. Oh no, here it is. This blue area, this is the Tibetan plain, and that's where the Himalayas are. And he talked about how those mountain ranges are so high and the glaciers are starting to melt, and because they're starting to melt, that this has been considered the third pole, because there's so much ice on these mountains in the Himalayas, and Mount Everest is up there, and these glaciers and these mountains provide water to about 2 billion people, all the way down into China and India and around, and that these glaciers now are starting to melt, and that as a result it's a problem, because if these melt even just like a third, if they go away a third, they won't produce enough water and stuff for the surrounding areas, and so it's a water problem. So it was an interesting video, and I learned a lot from it. So thank you for sharing that, Robert. And then he found also sites in the Arctic used for the FSU for dumping radioactive waste, or by the FSU. I don't know what FSU is, but I'm assuming it is the Russian dumping. So here's the map. Let's see if we can get a bigger one. Here it is, a bigger one. And so here's Novaya Zemlya, and then the green is liquid waste. The red things are solid waste. So it's all around. You can see And this, I read articles where this Kara Sea is the most radioactive sea on the planet. And they don't want to open it up to fishing because they're afraid that the fish are radioactive. And then areas here, a lot of liquid. How can you have liquid waste in the ocean? Unless it's in containers, I don't know. And then solid waste. I don't know what that would be. Reactor cores, and those are going to be like just melting through everything, and that would be melting the seafloor and releasing the methane, melting the methane and letting it come up, those whatever. So thanks for that, Robert. That's a really good site as well. So I appreciate you coming with that research, and thanks for being here. And then Going South says, hi Margo. This was under my video from yesterday. Hi Margo. Hi Going South. And this is Torstein from Greenland. He says, some ice news out of Greenland. Greenland summer ice cap calving starts early in 2019. Here's his YouTube video. And he took pictures of the ice coming off. And he says, comment, question and answer, when does it usually start calving? Answer, don't know, but it seems we're 2 to 3 months ahead of last year. So if you click on that, and I don't want to get a YouTube strike, so I'm not going to click on that. But it's a movie, a little short movie that he made showing the ice coming off. And so thanks for that report, Torstein. We appreciate it. And then Michael Berlin leaves a couple of comments. He says, thank you, Margo, and much love. You're welcome, Michael. Much love to you, too. And then he says, giving Robin credit for his site, meaning Robin Westendra. I was looking at his work and his contacts, which one was Mike Lee at climateviewer.com. Yeah, and that's a really good site. It covers a whole lot of stuff. I've looked at it. It covers it takes a lot of time to kind of get into it, but he covers a lot of he has a lot of research data there. Lots of places you can get research there. Mike Lee explains geoengineering like nobody else, the history of and present conditions with large-scale intervention by U.S. military and NASA rockets. I believe it. I believe it. So if you want to go to Climate Viewer, you can click there, and that's a good site too. Thank you, Michael, for that link and that research and that information, and thanks for being here. So I'm going to stick with my my recent videos for the comments. Then Ultra High Carb Life says, I look forward to your daily reports. Thank you, Margo. You're welcome, Ultra High Carb Life. Thanks for being here. Then Tom Bell says, thank you, God bless. You're welcome, Tom Bell. God bless you too. And then Richard Neville says, hi Margo, I use the Navy website to look at Arctic sea ice thickness, and I know you use the U.S. Navy website too. I've just been on there today and I can't see any up-to-date data. Everything seems to have been deleted after mid-2017. I'm really alarmed by this. I thought I was going mad, but I've tried looking through the website for up-to-date analysis with no joy. Here's the usual link so you can see for yourself. And the link that he's got here is to the old modeling system, and they switched modeling systems in September of 2017. And so I responded and I said, Richard Neville, that's the old modeling system. Here's the one they're using now. And then I said, here's the link for all the polar oceans too. And so this is I will be leaving both of these links in the description box under all my videos as well. So let's go over this, and I did a detailed explanation of this in one of my campfire chats. It was so if people want to know what happened, I go into the whole thing about it and how I figured out that there were two modeling systems, and Robin actually contacted Sam Carana to verify it, and Sam Carana said yes, there are two modeling systems. And so I will leave this link in the description of this video. This is my campfire chats from August the 9th, Arctic sea ice and climbing the ladder of awareness, and we talk all about it. And so they changed their modeling system, and here is the web page. And I don't even know how I found all of this stuff. I mean, months ago I click through everything to figure out that there was an old modeling system and a new modeling system. Now if you go to the old system, and I had been using that one, and it's still up, and it says the Arctic HICOM sea ice, and that's the old modeling system. And when you click on any of them, like sea ice thickness, the latest data is from October 17th, 2017. And that's what Richard Neville is talking about. And then Snapshot Archives goes back to 2012. You can, and this is all their data back to 2012, and I've done videos showing how to use all of this, so I'm not going to spend a lot of time doing that today. But they've got, so here's the page announcing as of September 30th, 2017, ACNFS will be replaced by the Global Ocean Forecast System, or the GOFS 3.1. And that's the new system that they're using now. Daily Arctic and Antarctic ice products are available from the GOFS 3.1 webpage, and they've got the link, and all you have to do is click there. The ACNFS webpage will remain in service for historical purposes, but will not be updated with the real-time ice forecast products. And then if you scroll down, this is the last day of data that they had on the old system, and the way you can tell it's the old system, it says ARC up here in the upper left on the picture. So you have to click here, and then it says polar oceans. You can click Antarctica, Arctic Ocean, Beaufort Sea, or Ross Sea. So then you go to Arctic Ocean, and then it says Arctic, and then this is the global HICOM system. And so that's different from the ARC. And so when you go to sea ice thickness, here it is from today. This is February 13th, 2019. And down here is the day that the data was read, and it was read on February 12th, 9/2/12. Okay. And the hour, that's the hour over there. And it was read on February 12th and projected for February 13th. And it says GLB up here. So that's the system, that's the current system, and there's the sea ice from today. Now the archives go back to 2014. You can go, so they had an overlap, and then for 2018 through 2019, they're found under Snapshot Archive, and then all the archives for this global HICOM system are found down here, and it goes back to 2014. So they overlapped from the ARC system to the GLB system. But Sam Carana suggested that we all use the same system, otherwise you're comparing apples to oranges. And so what I found is that a lot of people who use these pictures and stuff don't realize the difference between the two systems, and so the sea ice looks a lot thicker in the old system, and it's a whole thing. So you have to be careful about this, you know, what you're looking at. And so in my description box, here's what I'm leaving regarding the U.S. Navy polar ocean models. This is their explanation, and here's the link to that page with that explanation. And then here is the link to the Navy polar oceans, to the new system, the GLB system. And if you just want the Arctic sea ice, here's the link for that, to the new system. And I'm also leaving a link to my Campfire Chat show from August the 9th, where I go into great detail showing all of that and how I figured all that out. So that will be in the video description box below today as well. So I hope that answers everybody's questions about all of that. So thank you for being here, Richard, and you know, I hope you watch the video today, and I hope you read my responses that I typed in down there, and we'll get you fixed up so you can be looking at sea ice on current level. And then finally, Zoe McFarlane says, "Hi Margo." Hi Zoe. "I'm a new listener from down under. Here is some info from the antipodes taken from a local news article in New Zealand. A 2,300 kilometer long dust cloud is heading to New Zealand after blanketing parts of eastern Australia. Met Service duty forecaster Heath Gullery said the dust blowing across the Tasman Sea would likely reach the South Island and parts of the lower North Island this week. In Australia, strong winds picked up the dust and blew it across cities such as Canberra and Sydney, and also coated parts of the southeast of New South Wales. Gullery said the clouds were likely made up of smoke and dust from the large wildfires occurring in Australia. Thank you for your constant updates. Blessings." Well, thank you for the report down under, Zoe. That is disturbing news. I'm not surprised, though, considering the state of Australia and the droughts that y'all have had, the summer y'all have had down there in New Zealand and the Tasman Sea and everything. You know, it doesn't surprise me, but it's very disturbing. So we need to pray for everyone down in Australia and New Zealand that they're safe. Pray for their safety. So thanks for being here and for reporting, and we look forward to hearing from you in the future. So on that note, I'm going to close that out, and let's get to our earthquake report. Okay, what we're seeing here is USGS website with all magnitudes of earthquakes for the last 24 hours worldwide, and we're seeing 205 on the map. So we see that the number has dropped, but the magnitude is picking up, I think. And if we go, we're going to start with 2.5 magnitude and higher as we look at the international earthquakes. It's showing 42 on the map here. So let's see what the oldest ones are. So we'll cover those first. Here was a 2.9 near Puerto Rico that happened yesterday at 5:35 p.m. 2.7 near Koktovik, Alaska that happened at 5:44 yesterday p.m. 3.0 near Kobuk, Alaska that happened at 5:47 yesterday. Then a 2.9 in Puerto Rico. So let's start down here. We'll cover Dominican Republic and Alaska first, since those are the oldest ones on the map, so we can get everything covered here, and then we'll move around the world. So 2.5 magnitude and higher, we've got 10 here, and it looks like they're stacking up here north of Puerto Rico in the island. Look at that. I mean, in the water there's 9, including that one. So these are the highest magnitude. Here's a 3.1 that happened last night at 10:24 p.m. Here's a 3.0 that happened this morning at 5:51 a.m. and the others are in the 2s range. 2.9, 2.9. So those are getting pretty good size, and then one more is over here near the Dominican Republic at 2.8. So let's look at all magnitudes for this region now. We've got 15 on the map. So here we had 10, so we had 5 under 2.5 magnitude. And like here's a 2.4, 2.3. I mean, they're close to 2.5. Here's a 2.0, 2.1, and so forth. So that's kind of ramping up. Now let's move to Alaska. Open this up a little bit. And let's see how many 2.5 magnitude and higher we've got here. It looks like 8 on the map, so I'll just go around and call them off. 2.7 Koktovik, 3.0 Kobuk, 2.8 Redoubt Volcano, 2.7 Talkeetna, 3.0 Talkeetna, 3.2 Kobuk, 3.1 Redoubt Volcano, and 2.5 Koktovik. So it's like they're happening in pairs. See? One a little bit higher than the other. Now let's go to all magnitudes. And for the Alaska region, we've got 57 here today. And they average typically between 50 and 100 a day. And Alaska, as I say in almost all my videos, it's a highly active region because they've got a lot of volcanoes and it's just seismically very active. Here's the Anchorage area. Let's zoom in there. They've got 24 on the map here today. So So there were 8, 2.5 magnitude and higher. So 51 or 50, yeah, 49 that were under 2.5 magnitude. And they're in the 2s and under 2 range, most of them. So, and then even under 1s down here in that cluster near Anchorage. So there's that. Now let's get started. I'd like to start right up here in Russia in Kamchatka. This is the peninsula coming down. There was a 5.2 near ESO, Russia. This happened at 10:34 last night, 91 kilometers deep. And these times I'm telling you are Pacific time, because that's my time zone and the one I'm most familiar with dealing with. Then coming on down, this red line was there were 2 here, 3. There were 5.0 at 1:25 this morning, 5.0 at 2:02 this morning, and a 5.1 at 3:44 this morning. So these are big ones coming in all within the same area. So 2 of them right on top of each other. All from 1:25 this morning till 3:44. So just a little over 2 hours. Those 3 large ones came in right by that red line. That's the where the Pacific plate meets the North America plate there. Then moving on down into the Philippines, we have another pair here, 4.9 and near General Luna, and a 4.9. So again, we're seeing them in pairs. This is so interesting. Then here we have a 4.4 near Tobelo. This was in the ocean again, not on the island, but in the ocean. This was 112 kilometers deep, and it came in at 8:14 this morning. Then here's one, a 4.9 near Namlia. This happened at 1:32 this morning, 31 kilometers deep. Next, let's get this one down here by, this was actually on Java. This is part of Indonesia, a 4.9 near Karamat, Indonesia. This one happened at 3:41 this afternoon, 69 kilometers deep. Now that's big enough that could do damage. That's very near 5. That could definitely do damage depending on if it was in a populated area or not. So that happened this afternoon. Then moving on over to Papua New Guinea, here was one near the Southern Highlands, a 4.8 near Mendi, Papua New Guinea. This one happened at 12:59 this morning. So you would feel that. You would feel the earth moving with a 4.8, like a rolling. Here's a 4.9 near Sola, Vanuatu. This one came in at 2:38 this morning, 35 kilometers deep. Then we have 2 coming down this red line. We've got Okay, we saw that one. We've got a 5.1 south of Tonga that came in at 2:53 this morning, and a 5.0 near L'Esperance Rock, New Zealand. This one came in at 8:07 last night. And L'Esperance Rock is an island up here north of New Zealand. So it was in the ocean here. So with it being in the ocean, it probably didn't do any damage. So that's all of them on that side of the globe. Now let's move on down here. We had two in the South Sandwich Islands region, a 4.9 near Viscoy Island, South Georgia, and the South Sandwich Islands. This one happened at 9:56 last night, 35 kilometers deep. And then this one right here on the red line too, a 4.9 in the same region at 5:21 this morning. So we had another pair there. They're coming in pairs, it looks like. And then down here in Peru, there was a 4.9, 1 kilometer northwest of Yaha. Is that how you say it? Yaha, Peru, at 9:03 this morning. I don't even see it. Oh, look, here's the little town. Now that could do damage. It was 1 kilometer northwest. That's 1 kilometer. So that could have done some damage if people were living nearby there. Look, there's an airport there. Moving on up was one off the coast of Costa Rica in the ocean. This one was a 4.5 near Capos, Costa Rica. This one happened at 11:23 last night, 34 kilometers deep. And Costa Rica has 4 active volcanoes. So we've seen earthquakes near Costa Rica before too, and it's right on the red line, so I'm not surprised. So now let's move on up into the lower 48 United States, and here's our 2.5 magnitude and higher, but let's go to all magnitudes now. And we're going to start with these over here in Oklahoma. We've got 3 lined up here. I'll call them off. A 2.2 that came in at 10:31 last night. 3.4. Oh, that's... Wait a minute. I didn't mean to do that. Hang on. This 2.2 was near Chickasha. This 3.4 was near Hera, Oklahoma. This one happened at 8:39 this morning. And then a 3.2 near Pawnee, Oklahoma. This one just came in. It was at 4:48 this afternoon. So they're kind of in an arc here. Now moving on over to Utah. Here's one right on the Utah-Arizona border, a 2.1. This one came in at 3:38 this morning. Then over here at Farron, Remember we saw all those yesterday? It's still swarming. We've got 7 on the map today. But I want to show you something. Now, none of these are minus kilometers depth, so they're in the ground. But these are 1.5, I'll call them off, 1.4, 1.3, 1.8, 2.2, 1.4, and 1.3. So I want to show you something. If we go to, if we change our settings to 7 days, all magnitudes, look at all these earthquakes here in the last 7 days. They're 51. Starting on February the 8th. Just one here and there, and then starting on the 10th, they started coming in every few minutes. So here it is, the 12th, and they're still coming in. So I don't know what's there. I don't know what is causing it. I just don't know. So let's go back to all last 24 hours, all magnitudes. Now, coming up to north of Orem, we have another cluster. We've got 4 here near Bluffdale, 1.9, 1.8, 1.4, and 1.2. Then here's one in the middle of the Great Salt Lake, 1.4. This one happened at 9:03 last night. And now moving on up into the Yellowstone region. See if we can get them all on here. There. Okay, that's all of them. We've got 5 here, including a 2.0 magnitude created from a quarry blast near Butte, Montana. This came in at 12:04 this afternoon at a -2 kilometers depth. So that was up on the hillside or in the mountain that they're blasting. They're still blasting. So I'll call these off. 1.3 Lincoln, Montana. 1.6 Pablo, Montana, up here. 1.0 Pablo, Montana, same place. There's our quarry blast. And a 2.2 near Three Forks, Montana, down here. So there's that. Now moving on over into the Pacific Northwest, we have this one that came in on this Juan de Fuca plate at 4.8 near Port Hardy, Canada. This one came in at 4:34 this afternoon. You see the wave there? We can look and see if there's a tsunami warning from that. So we look down here. And what magnitude was that? A 4.8 near Port Hardy. That's got to be the same one. Hang on. That's got to be this one. They're calling it a 4.7 here. And then we click over here for the tsunami warning, and it says this is a tsunami information statement for Alaska, British Columbia, Washington, Oregon, and California. There is no tsunami danger from this earthquake. And then they give all the details of the earthquake and the coordinates and everything. So that's how you can see if there's a tsunami warning. And then if there was a warning, they would do updates over here. But you have to find the earthquake that it's associated to. It took me the longest time to even figure out how to find tsunami warnings. So, and there were two here. Look, we're seeing them in pairs. There was a 4.8. That one happened at 4:34 this afternoon. And then there was a 4. Okay, before that there was a 4.1 that came in at 2:53. So less than 2 hours apart. They're literally on top of each other. And this is that Juan de Fuca plate in between the North American plate and the Pacific plate, and this is the Cascadia subduction zone. Then we've got another one right down here on the southern edge of that plate, 3.5, that came in at 2:13 this afternoon, right there. So there's definitely movement going on. So these plates are moving. So something's up. Something could happen. And then a 2.8 near Hayfort, California. This one came in at 6:38 last night. 35 kilometers deep. Let's look at Nevada real quick. Here's one north of Reno, 1.6 near Cold Springs. It was up in the mountains. That one came in at 12:16 this morning. Nothing down at Lake Tahoe or Carson City. Here's this one near, they're calling it near Gardnerville, but it's across the border in California. A 1.5 that came in last night at 10:26, 0 kilometers depth, 10:26 p.m. And it is eerily quiet in Nevada. Look at this. Nothing in Hawthorne, nothing coming down in the Nevada test site, nothing, nothing, nothing. Look at this. Here's a little tiny one. Here's a minus 0.1 near Beatty, Nevada. And here's one, a 1.8, 19 kilometers east-northeast of Nellis Air Force Base. Here's Nellis Air Force Base here, and so it's right up here. This one came in at 4:07 this afternoon. 10.3 kilometers deep. That's it. That is it for Nevada, unless something else comes in while we're still online here. Let's change it up a little bit. Let's come on down this eastern side of California next. This is the Mammoth Lakes and Long Valley area. We're showing 9 here today. Get them all on the map for you. I'll call them off. 1.6, and you can see them light up blue wherever I call them off. 1.6, 1.3, 1.0, 0.9, 0.7, 1.2, 1.0, and a 0.6. Now this 1.0 right here, it was, I didn't mean to do that. It was a minus 1.3 kilometers depth. So it was up in the mountain, so that's showing movement of magma up in the mountain. And there's volcanic tableland, that's what it's called. There's old volcanoes all the way through this area. So any of these volcanoes could come back to life. So that's why we're looking at these so closely. And even the little ones, they count because it shows movement. Here's a 0.7 near Coso Junction. A lot of people just skim over the little ones, but I think they're important. Here's a 1.5 near Lake Isabella. Where's this one? 1.1 near Yucca Valley. Now let's go back to our 2.5 magnitude and higher. So let's see, we had a 3.0 down here. This was in the Kauai area, Aguanga, at 11:38 last night, 6.2 kilometers depth. So it's buried under all of these. So here's this Los Angeles and Southern California area. So see if we can get all of these on the map. We only have 32 here today. That's low. That's a low reading, but they're mainly clustered right down here. Here was that 3.0 that happened. And then the rest of them are quite a bit smaller, as you can see. This is an active area, and this is the Kauai Indian Reservation right next to it. Now, let's come on up. This other side. Here, we saw that one, Isabella. Now we're going to follow the San Andreas fault line up. 1.9 near Simler. And these are right on the red line. 2.2 near Pinnacles. Here's one near Concord, or Pacheco, a 2.0. And then the geysers is very active today, 29 here at the geysers. So that's very active. And they're small. They're in the ones and under range primarily. So we got all of those. 2.6 hay fork. So let's back out, just zoom out and see if there's anything that came in just now. Did we see that one at Pawnee, Oklahoma? We had 3. Let's zoom in and see what we've got. Let's go back over. I think we saw that. I've got a brain fart. I can't remember. Yeah, we showed 3. We showed those. And we showed this 4.8 near Port Hardy, Canada. We showed the 4.9 near Karamat, Indonesia, I think. Yeah, right on the land. Yeah, we showed that. So that's a wrap. I think that's it for today. So I'd like to remind everyone that time is very short. No one knows the day or the hour, and time is running out for you to get your spiritual house in order. And so, if you haven't done so, I encourage you to consider calling on Jesus. Say, Jesus, if you're real, come and show me and help me. Ask Him to help you with what you need help with. If you need a healing, if you need guidance, if you need comfort, because He's there. He's there for people. And the church is taught that we can't go to Jesus directly. And so I've learned from my own experience, and a lot of other people have too, that when they call on Jesus, He makes His presence known to them in wonderful ways. So I encourage you to do that. So until next time, God bless each and every one of you. I love you very much. Go in peace, and good night.